Good morning, everyone. My name is Suman Singh, and welcome to the third lecture of atomic structure. And today we are going to learn about it. In the last class, we have discussed about the Thomson plum pudding model. So, but that model has been lasted for some years, but because J.J. Thomson was a famous scientist, and since he has discovered electrons, so whatever the plum pudding model he has given, that model has lasted for few years. But after some years, one of the scientists named Rutherford, he has done one experiment, and from that experiment has we can say like this, that experiment has changed the way of looking at the structure of atom. So we will discuss about that experiment. Since Rutherford has done this experiment, before that Henry Becquerel has already discovered radioactive elements and radioactivity. So one day Rutherford has decided to do one experiment. So his experiment name is Rutherford experiment. We will see that. So now what he has done, he has taken in a container, he has taken an alpha particle. Okay, here he has taken alpha particle, and that one he has sealed that container with a thick wall of lead. Okay, now we will see the experiment. What he has done, he has taken here what alpha particles, which we have learned on the discovery of neutron, when we were discovering about the neutron's discovery. At that time we have seen alpha particle. So he has used alpha particle here, and what he has done, he has passed that alpha particle in a thin sheet of gold. Okay, here he has used a thin sheet of gold, and he made that alpha particle to pass on that thin sheet of gold. So what he has observed, most of the alpha particle has directly hit this thin sheets and gone straight like this. Okay, but what he has observed, some of the alpha particle after striking this gold fuel has deviated with a small angle like this, deviated with a small angle. We can say that 1 in 200 particles has deviated with a small angle like this. Means what we can say, if 200 alpha rays are striking the gold fuel, only one of them is deviating with a small angle. And in 1 in 20,000, we can say that 1 in 20,000 rays bounced back, means they have completely turned back with a 180 degree angles, has bounced back. So what he has observed, his observation, if we talk about the observation, what he has observed, that most of the alpha particle passed through the gold fuel without any deviation. Okay, number 2, some of the alpha particles were skirted by a small angle. We can see here, deviated with a small angle. Now, and very few, what we can say, 1 in 20,000 particles has deflected back, or we can say that they have come back with a 180 degree angle. Means just like this, you can take like this. Suppose this is a positive charge here. Okay, and since we know that alpha particle is also a positive charge, so when any alpha particle will come here Suppose here it is an alpha particle, here is also an alpha particle, here is also an alpha particle, here also alpha particle. So if this alpha particle is coming, you can see there is not having any connection, so it will go straight. But some of the alpha particles will, when it will come, it will deviate like this. In the same way, if it will come if any alpha particles has directly hit that positive charge, it will bounce back, because both are positively charged, and we know that positive repel each other. So he has concluded like that most of the rays pass through the fuel without any deviation. Some of the alpha particles are scattered with a small angle, we can say that like this, and 1 in 20,000 has bounced back. So this was the Rutherford experiment. So from this experiment, what he concluded, that most of the space in an atom is empty. We can say that most of the space in an atom is empty, okay, and positive charge and most of the mass is concentrated at a small point, which is called nucleus. What he says, if we consider an atom is just like a cricket ground like this, then the nucleus will be just like a ball which is placed in the center of the ground. So he says that, and that nucleus contain both proton and neutron. Means what we can say that then positive charge is concentrated into a very small point, or we can say that in a very small space in an atom. If we are considering atom as the size of the cricket ground, then if we place one ball in the middle of the ground, that will be the nucleus. Okay, now next, what he says, volume of the nucleus is, what we can say, volume of the nucleus is negligibly small compared to the volume of an atom. Okay, just I have given you the example of that cricket ground. After that, so J.J. Thompson experiment, what he has told in that plum pudding model, after looking this experiment, that experiment has completely failed. So since J.J. Thompson experiment has failed, so Rutherford has given one idea about the atom. So then what was the idea? That he told that just like our solar system, the planet revolve around the sun, in the same way electrons, protons and neutrons are in the middle, and the electron revolve around the nucleus, just like this, just like our solar system. Okay, so this was the experiment, Rutherford experiment. But this Rutherford experiment has not means we can say that this Rutherford experiment was not successful, or we can say that it has some drawbacks. What is the drawback? We will see one by one. Two major drawback was, as we know, you have learned in physics, if any charged particle is there, suppose there is a charged particle here, and if this charged particle is rotated by any other charged particle, then what it will do, this charged particle will release their energy. Okay, at time, if it is releasing an energy in the when it is revolving around, then one time will come, this electron will go and collapse in the nucleus. Just like in the Rutherford, what he has said, that electron revolve around the nucleus. Since electron is also a charged particle, and proton and neutron, which is in nucleus, this is also positively charged. Then if it will rotate like this, then what will happen? Slowly and slowly, electron will release its energy, and when time will come, it will collapse here. So this was the first drawback. Okay, now number two, he has not explained the distribution, but we can say that it cannot explain the energy and distribution of electrons around the nucleus. Number two, what he says, since this theory has failed here, then we can say that he has also not explained properly the distribution of electrons and distribution of electrons and the energy of the electrons. So this was all about the Rutherford experiment. Now one or two terms after that, after Rutherford experiment, we will study Bohr model. Okay, so before studying that Bohr model, we will see some of the terms. After that, we will go to Bohr model. So as we all know, what is atomic number and mass number concept, which I hope you have learned in class 9 and 10, 11, 9 and 10 about atomic number and mass number. Okay, so we will, and today we will see some of the terms just like this. Suppose this is an helium, and helium is there. We write here what we will write here 2 and 4. So this 4 is what? Its mass number. This 4 is what? Its mass number. And this 2 is what? Its atomic number. Okay, so this was atomic number and mass number concept. Now three terms we will see here. One is isotopes, another one is isobar, and the third one is isotone. Okay, so what is isotopes? I know all of you know about this. Isotopes is what? Same element having same atomic number but different mass number. Means element having same atomic number but different mass number is called isotopes. Okay, now number 2, if you are talking about isobar, then what we can say? In case of isobar, same mass number but different atomic number. You can take so many examples like this. You can take argon, you can take potassium, or we can take copper. Example of this. Okay, so same mass number but different atomic number. And now next is isotones. Isotones is what? Same number of neutrons. Means what? The neutrons will be same, just like in the case of, you can take the example of oxygen, nitrogen and carbon. I will tell you what are they. Carbon 614, or nitrogen you can say 715, and oxygen is 816. In all the three cases, the number of neutrons is same. So this is called isotones. So once again I will repeat. Isotopes is what? Same atomic number, different mass number. Isobar is what? Same mass number but different atomic number. And isotone is what? Same number of neutrons. So this was all about the Rutherford experiment and isotopes, isobar and isotones, and atomic number and mass number. So now in the next class we will, before going there, I would like to give you one question, which I hope you will. I will give you one question. You try to solve that question. I hope you have done that type of question in class 9 and 10 also. So suppose the question is the answer of this question I will solve in the next class. Okay. So before that, suppose the question is silver is what? Suppose it Z is equal to 47 is given. Okay, and it has 46 known isotopes. Okay, but only 2 occur naturally. Okay, which is Ag107 and Ag109. So what we have to give? We have to give the following data calculated calculate the atomic mass of Ag. Okay, so what I am giving you the following data, which is Ag107 is 106.905 U, which is 51.84%, and Ag 109 is 108.904 U, which is 48.16%. So now you have to calculate what? You have to calculate the contribution of 107 Ag, contribution of 109 Ag, and atomic mass of Ag. Okay. So this was the question, and you try to solve this question and post it in a group, or you can send me the personal message of this group by solving the answer of this question. And in the next lecture I will discuss first this question, and after that we will learn about Bohr atomic model. Okay. And because in Bohr atomic model, before learning Bohr atomic model, we will see some of the basic terms which we will use before starting Bohr model, that is electromagnetic radiation. Okay. Regarding electromagnetic radiation we have to learn. After that we will start with Bohr model. Okay. Up till that, thank you.